Today we need to take a look at linear and non-linear equations. And we'll look at it in two different formats. We'll look at it on the coordinate planes, the graphs, and we'll also take a look at the equations. And the goal is that at the end of this lesson, you'll be able to take a look at it, and within just a couple of seconds, you'll be able to classify it as being linear or non-linear. So the word linear, if you notice, it has the word line in it. And so if we take a look at a graph, if it makes a straight line, we would say it's linear. So there we go. That's a straight line on a graph. We would call that linear. That would also be linear. Now, when we look at the word non-linear, obviously the word line's in there also, but the word non is attached to it. So basically, if it's not a line, if it's not a straight line, would be non-linear. So when we look at a graph, if it's got a curve in it, definitely not linear, it's non-linear. See this blue S-curve type right here? That's a very strange curve, definitely non-linear. But this red line right here, that would be linear because it's straight. So that's the basic difference when you're looking at graphs of lines to determine whether it's linear or non-linear. The challenge really comes down to when we look at the equations. See what I'm saying? Look, the blue lines are non-linear, the red lines are linear. So for the equations, when we don't see those graphs, we've got to be able to look at it. And there's one basic rule, and for 8th grade math, it'll work probably 95% of the time if you can just get this one rule down. And that's where you take a look at the equation, focus on the variables, the y and the x. And if you don't see exponents on the variables, then you'd say it's linear. Okay, so let's take a look at another one. There we go. There's our equation. Focus on the variables, the x and the y. And suddenly we go, hey, there's no exponent, so it's linear. What about this one? Well, the x has an exponent of 3. The y is okay in this case, but the x, it's got the exponent, so it's non-linear. And I actually need to change that. That was a mistake there, so we'll do that right now. Non-linear. There we go. What about this one? It's a negative exponent. That's fine, but because that exponent's on a variable, we have an issue, and we would call that one, well, geez, the same issue as before. It should be non-linear. It's also at this point I would like to mention exponents don't mean that the equation is instantly non-linear. You've got to make sure that the exponent is with a variable. If that exponent was on a number like the 8 or the 6, we don't really care. Now, the other rule, and this is kind of just a homemade rule of just trying to put it in terms that an 8th grader could understand. If you see an x on the bottom of a fraction, or if you see an x inside a radical sign, just trust me, if you go to graph it, it's going to be a bent curved or a line that stops and zigzags and does all sorts of weird things that is not straight. So if you see an x on the bottom of a fraction, or if you see an x inside a radical sign, consider it nonlinear. So here we go. Y equals radical x plus 5. Because that x is in a radical sign, call it nonlinear. What about this one? Again, we see straight from this number 2 rule, the second rule here, if you see an x on the bottom of a fraction, I don't care if the x is on top, guys. I care about if the x is on the bottom of a fraction. We must consider that non-linear. Here we go again. This x is on the bottom of a fraction, so we will consider it non-linear. And then this is pretty much the last part I need to go over. This one's not necessarily with the second rule, but it's this idea of when you're taking a look at an equation, if you can simplify it, it really helps you out as far as being able to see what's really there. We have parentheses right here, so 3 times 3x and 3 times 3, we would get y equals 9x plus 9 after the distribution, right? So we have to consider that to be linear because the y's, after we've simplified it, have no exponent. And that's the main thing. These parentheses kind of get in the way, so get rid of the parentheses if you can, and then check your variables, and that's the same rule as rule 1 up here. And actually, let's do one other. How about this one? Y equals, we'll have 3x on the outside. We'll have 4x on the inside minus 3. So since we've got these parentheses right here, we need to get rid of them with distribution. And this is where it gets interesting. Y would equal 3x times 4x would be 12x squared. Well, that square on the x is everything. That's a problem. And 3x times negative 3 is negative 9x. But see this part right here? That's the reason we have to consider it nonlinear. So just be on the lookout for parentheses. Be on the lookout for x's on the bottom of fractions. Be on the lookout for x's inside radical signs. However, that's only going to show up probably like 5% of the time in 8th grade math. What we're truly looking for is this setup here. Just look at your x and y's and make sure they don't have variables. Okay? If they do, it's nonlinear. Right? Nonlinear.